Okay, so the whole process begins with glucose, and glucose is split into two G3P molecules. And then each of those G3P molecules becomes pyruvate. This process uses 2 ATP and creates a total of 4 ATP. Meanwhile, the same process produces 2 NADHs, one on each side. These 2 pyruvate now that were in the cytosol are going to enter into the mitochondria. In this transition step, the pyruvate come in to the mitochondria as 3 carbon compounds. They each lose a carbon as CO2. And they also each make 1 NADH. Pyruvate has now become acetyl coenzyme A, and is ready to enter into the Krebs cycle. The Krebs cycle is also known as the citric acid cycle, and it starts when oxaloacetate, or OAA, combines with acetyl coenzyme A and forms citric acid. In their remaining time, we see the reduction of NAD at 3 separate places. As well as the reduction of FAD as well as 2 more carbon dioxides leaving. So we have our 2 carbon acetyl coenzyme A, as it lost a carbon from pyruvate, joining up with 4 carbon oxaloacetate to make a 6 carbon citric acid, and then we see the removal of 2 carbons as each one cycles through. At this point now, these are going to head to the electron transport chain, which remember is in the inner cristae membrane. So if this is my outer membrane, I'm going to go ahead and put an inner membrane here, and we'll make our electron transport chain. Oh, I did forget to include here that there is an ATP made. So we're now to this inner cristae membrane, where we have an electron transport chain. And all of the NADHs made throughout this process as well as the FADH2s. So all of these are going to head over here. Everybody on its way to this electron transport chain, including the FADH2. At this moment now we get the separation of the electron, that it gets dropped off at the electron transport chain, and we get the creation of the proton gradient in the inner membrane space. And as the electron travels down the electron transport chain, it eventually is going to drop off onto oxygen, making water. The electron from here, and then remember we also need to get our proton, which is going to be traveling through the ATP synthase molecule. And as these protons build up, we're going to use the energy for one of them coming through, joining up with this electron and the half of an oxygen, and we end up with H2O. Which is one of our main products of cellular respiration. And along the side, we get the production of ATP energy. Remember, we're talking about making 28 of these. So as we look through our whole reaction here, from glucose to pyruvate to acetyl coenzyme A, 2 turns of the citric acid or Krebs cycle, all of those NADHs and FADs going to the electron transport chain, and finally turning through the ATP synthase to make ATP, we get a total here of glucose, C6H12O6 glucose, and which make carbon dioxide, and water. And as a byproduct of all of this, we see the production of 32 ATP molecules. And this is why we do it. We don't do this process to make carbon dioxide or water. We do this process for the 32 ATP molecules that are made as a byproduct. And so, in a nutshell, we have cellular respiration. Good job, guys. Nice and complicated. Way to get it done.